Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Bart Cremers. Bart is Group Knowledge Consultant at Zehnder Group International, an experienced consultant in the building materials industry, a consistent presence in the air quality space in Europe, and ever present at conferences and in research. He has deep knowledge of research and development, physics, renewable energy, data analysis, and business development. Zehnder is a leading global provider of complete ventilation solutions for healthy indoor climates, and in his role, Bart occupies a fascinating position straddling the world of industry and academia, research and innovation. And it was this I was keen to talk to him about how industry and academia can better work together, understand each other's perspectives, and ultimately improve the lives for everyone indoors. I've had many conversations about this subject with Bart, so it was about time we sat down and got this on tape. There is so much the industry can do for science and the other way round, but there is sometimes this almost inevitable friction and reservation that comes from engaging with industry in research. So how do we start to unlock this potential? Bart's perspective on this is really interesting as he navigates these challenges in his role. I hope you enjoyed this episode as much as I did. Please don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Bart Cremers. I remember once I was involved in a research project with Erico and a bunch of people looking at something to do with demand control ventilation. I can't even remember what it was now. It was a presentation around standards or something, but it was quite formula heavy, kind of maths heavy. Yeah. And we were due to present it at the AIVC in one of the sessions, and the speaker couldn't make it last minute, so they asked me to deliver the talk, and there were a lot of people in the room that were really interested in this subject, both for and against some of the ideas in it. And I really got grilled on it. It was one of those ones where there's loads of questions on it, and I was so out of my depth. I was a tough time then. I was it was a long time, and it was my really early days in the AIVC as well. So there was a lot of peers there that I would have looked up to a lot. So I don't think I've ever been as nervous presenting.
It's totally all right when you tell once or twice it's work from my colleague, etc. Blah blah. But if for the fifth time, then you're a bit.
Yeah, you're just bluffing it. Yeah, there's only far you can swing it. Well, it leads us into it really nicely, I suppose, and it's that we see it so often, don't we, at conferences, the potential of industry to contribute to scientific understanding and learning, and there are individuals, I think, that you see time and time again, and you're one of them, Bart, that straddle this gap between industry and academia quite frequently.
I hope.
Yes. Yeah. Both because you're at the forefront of research and innovation in the organisation that you work with, Zehnder, but also because you've been in that field for a long time as well, and so you understand very well both sides of the fence. Was it T&O you were involved in back in the early days as well? Did I read that right?
Yes, from my military service where I did research for the defense. There was a T&O institute there, and I got into the T&O institute and really learned how to do research in a research group. Yeah.
So like you understand both sides of this coin really well, and I think the interesting thing here for us to discuss is, and we've spoken about it before, is how industry and academia can collaborate better and share knowledge better, because it happens, and you're doing it all the time with the work you do with Zehnder, but there's friction there as well, isn't there? And understandably so.
It just crossed my mind that when I was brought up, and it turned out that there was I was into beta and physics, etc. And I know that my grandfather once said, "Okay, that's very good, but don't let him be a professor. Let him be a man of society." He told to my mom, and I thought it was not a deliberate choice, but in the end, I think I tried to cross both worlds because in industry you can do something with it. You can train other people. You can take it into practice, and this is what I liked. So with some fundamental background, you can really cross the gap to the practitioners.
Yeah. And I wonder if it's nurture and nature sometimes at play with the differences with characters and worldviews and perspectives between industry and academia, because, undoubtedly, I think people are wired a little bit differently in one sector and another. And I don't know if it's accidental, you just fall into academia or you fall into industry, but or whether over time working in those environments form you. I imagine it's both, to be fair.
Exactly. I mean, life is like a marble. How do you circuit? And you have many intersections and crossings, and you take with every choice you take the best choice that you have at the moment, and it leads you to where you're good at.
Yeah, and I suppose also you're surrounded by peers that people that influence you and guide you as you progress in your career as well. So they kind of help form your worldview. Um,
Yeah.
but what you end up with often it is two silos um, that are often working on very similar subjects, trying to solve similar problems, looking at the world from different viewpoints, but nonetheless working on the same problems. And in our world, the built environment world and buildings, there's a lot of crossover, isn't there, between a lot of the research that's happening in academic circles and the kind of problems that businesses are trying to solve at the end of the day.
I would say the goals are a bit different, of course. Although one goal is exactly the same, we want good air for most people in the world. So um, if we have that in mind, then there should be enough interconnections and how do you say mutual
Yeah,
goals.
mutual goals, mutual benefits. Yeah, I know exactly what you mean. Yeah,
But the funding is different. The environment is different. So you are led by other incentives, let's say.
yeah,
Academia is more like an interesting problem, and I sometimes think also we're doing with this in the faculty or in the group that we are. So we go on with it, whereas industry is led by technologies that can bring innovations for their products.
yeah. I know what you mean. I I suppose one of the freedoms that comes with academic research, I suppose, or looking at problems from an academic perspective, is you're not necessarily tied to the commercial imperative that comes with business. Um, you have a little bit of space to perhaps look at problems over and over again, or to look at problems where there might not be a solution or an obvious commercial benefit out the other side of it. So, I think I think there's a clear advantage to that world that they can identify things without the pressure necessarily that might come from an industry side of things.
Yeah, although my personal experience is different from that. It's not entirely restricted to that because um, as I see myself in Zehnder, I am the scientist under the engineers, and when I cross the bridge to academia, then I'm the engineer under the scientist. That I must say, but I have quite a bit of freedom here in the company to have a look at interesting things that might not be led directly by the market. And that gives me the freedom to explore areas that are interesting, not for over 2 months, but maybe over 2 years.
Yeah, that's, I imagine that's an advantage of a much more mature company, one with the capacity to create freedom for people like yourself to do that kind of work. And businesses will be at all sorts of different life stages. You know, I've been in startups where you don't have a fraction of a second to waste on anything that's likely to distract you or deviate from mission critical endeavors, you know, all the way to small to medium entities where there's still a lot of focus. But you may at a group level be a fairly big company, but at a business unit level, you have to really work hard to keep things moving. And things can be very tight. But you do get to this point, and you see it in business quite regularly, where companies that have that in their DNA, and I know Zehnder's one of them, and I was very fortunate to work for a company like that also, where it's in their DNA to investigate and research and innovate, and that there's a longer view taken of these things, and they understand that if you give these things the space, that's where the true innovation can come from. You know, if you don't give people the time and freedom to look at these things in different ways and from different angles, you can get blinkered and find yourself down dead ends that don't do the business ultimately any good.
In my case, also what helps is not only looking at innovations, so not only looking in the future, but also know your history very well. So how do your products and solutions behave at the moment? So my role also in the company is to give proof of the technologies that we have in the house. So that's what I'm trying to do best, to see with monitoring studies how our installations behave in an uncontrolled environment, like a family in a house lives, with all the abnormal conditions that you might have. I mean, we have a lot of laboratory facilities here in the house, and we know exactly how the products behave in the controlled environment. But for me, it is very interesting to look at the installations, how they behave in a real world. And if you know that, you know your history, and then when I see good stories, I tell them right away to everyone who wants to hear it, of course. And when I see rooms for improvement, I take them to the R&D department and say, "Hey, you can improve a bit here or here," and give a recommendation. So that is really a nice view that I can give to the company.
Yeah, and that's a nice view that we can give to academic research as well. I mean, that's for me, and this is what started this conversation with us in the first instance, was this. Both of us come primarily from industry or work primarily in industry, and we see the benefits all the time of those touch points that industry can bring to research that just aren't available when you're cosseted within the comfort of academia. I'm not saying it's a comfortable place, but it's somewhat separated from the real world often, and industry operates very much at the coalface. So it gives that perspective. It has those touch points with ultimately how these solutions and how this research manifests out in the real world, and that is incredibly valuable, because you can't, you know, the gap between the lab and the home is enormous, isn't it, ultimately?
Yes, true. Various conditions, various set points for the preferred conditions for end users. So for me, it is nice from the monitored projects to tell stories. I rather tell stories than specs to people. And I am also a little bit, I have the feeling that people buy a product for the first time based on specs, because they take brochures, and a buyer from a company they just look in the brochures, and they compare A with B, and then you pick the one that suits your problem best. But to my idea, people stay with a company only based on the real world performance and experience. So you have to tell these stories how your installations behave in the real world, and from that you can build up a good relationship with the people that you're working for.
I'm smiling because you're reminding me of a conference I went to not so long ago that was unusual for me to attend. I hadn't been to one, and it was a real stark difference between how different worlds communicate. So I was just making the note there about communication. One of the things that industry can do very well, often because it employs people to do it, is communicate very well. You know, it really has to consolidate its thinking into many different formats, because it has to sell the idea, whether it's at the coalface actually selling the product as an idea, or whether it's selling that idea to regulators or to technical people or whatever. You know, that there's a whole mix, a whole chain of communication that happens in industry that really makes you think and rethink the positioning of an idea, that how you technically communicate it, how it's going to resonate. You know, there's a lot of work goes into that. And I was at a conference, an air quality conference there in the UK about a year ago, and it was and it's an organisation that predominantly supports consultancy firms. You know, big kind of environmental science consultancy firms, right? So this is very, very academic heavy stuff. You know, almost identical content that you'd see at an ISIAC conference or an AIVC conference. But it was curated by very slick, big consultancy firms. And that manifested to me shockingly in the presentations. It was unbelievable, the difference between presentations and how this information was being communicated, because it had come through the machine of a big organization, versus the presentations that you see at conferences. And you know, there's kind of that funny trope, isn't there, of the academic presentations where they still look like the presentations that were being done off gels, you know, back in the 80s, where there's cartoons and things being presented, and, you know, outdated graphics, and, you know, it's they can be pretty hard work to wade through. And that's an obvious difference between the world of academia and the world of industry, that industry can't afford not to communicate really well and rethink it. On the other side of the fence, though, what I thought was interesting is some people said, I don't like that. I quite like the raw presentations of academia, because it hasn't been overthought. You know, you know that presentation that's come through from Burrow Happold or whoever the big consultancy firm is, that's been through about 4 or 5 people by the time it's allowed out into the wild, and it can be a bit sanitized and vanilla and a bit corporatey, and you lose a little bit of the realness. So it's funny, isn't it? It's almost a manifestation of the differences between the two worlds, actually, the presentations.
Exactly, and they're also clear in the company that I work for, because I see my presentation as just before the how do you call it, the sanitizing. So it's really what I monitor, what I measure, what I think in clear graphs, and then of course, if we're on the market with a certain solution, then we get more people to look at it to build the whole picture.
Yeah.
And that's perfectly fine. And that's also in the comparison between industry and university. Of course, it's clear that you need both worlds, and both have something wildly interesting in it. But to bring them together, uh, you need to know both sides of the metal. What is both sides of the coin?
Yeah, absolutely.
Um,
Yeah.
and then you can bring them together, and that's, I think, my ambition within my company. But I know it's also the ambition from, for instance, the Industrial Advisory Committee that we have at AIVC. There are more people that link industry to university there, and I think that's a brilliant group to do that.
Yeah, and for listeners and for context, I chair the Industry Advisory Committee for the AIVC. And for those that don't know the AIVC, my apologies for all the acronyms. That's a group within a broader group of researchers under energy and buildings and communities. So there's a whole bunch of research and groups that work under the remit of the International Energy Agency, and this is one of them. And one of the things that the AIVC, which is the Air Infiltration and Ventilation Centre, has tried to do is to work a little bit more closely with industry in the right ways. And that's a group that I chair and Bart sits on. And this is how this discussion actually started. Was this how and actually it was one of the next questions I had to ask, and it kind of fits under, like, this isn't seamless. There's huge, and we've just been talking about it, huge opportunity for both industry to bring a lot of value to academia, but the other way round. I mean, I think it'd be fair to say, wouldn't it, Bart, that when you work with researchers properly and you undertake rigorous peer-reviewed work in academia, it brings a rigor and a lack of control that can be healthy to that research. There are other people involved and other stakeholders that bring a scientific rigor and different perspectives to work. That means it isn't just an industry-led piece of research. It can be, you can do some really good work, can't you? And academia can bring a lot of benefits to industry when industry gets involved in this work. And I know Zehnder have done that over and over and over again, is being involved in these broader pieces of research and contributed as part of a bigger collective to knowledge, and that helps the company as well.
Yes, I need the universities, the academia, to supply me food for thought, and to bring the ideas that I could bring into technologies in the product. But the funny thing is that we have it really materialized. We have it materialized, yes. So we can also show, after it has been put into a product, how it brings an advantage compared to before. And that's really good, that we as industry can bring to academia again. Does it really help in practice? Something that has been researched 10 years ago by university can be shown already, because we have the technologies maybe inside our units. For that, sometimes this brings the funny fact also that the university is doing a research and comes with recommendations for future innovations, but we have it already in house. It's on the market already. So I sometimes stand up then and say, okay, that's a good thing, but we have it already. And then I invite people to chit chat, of course. Yeah.
And I think that's a reflection perhaps of the speed of progress of technology sometimes, that the innovation and the need for leanness and speed and the ability to fail quickly and progress really drives industry. And it means that, and this is a conversation I know you and I have had, is that, just by the nature of the speed that research works at. I mean, if you think of the life cycle of a big research project, it might be a year or two in the conception of thinking about how it might, how you have to have the right PhD students and the right people
Finding
around.
funding,
Yeah, then the funding comes around, but that might not come around that year or at the end of the year. So you might be
exactly.
ready in January, and then it's December before it comes through, and then it's really March, April before that starts, and then you get up and running and you start doing some stuff. Then you have to go and find, especially if it's field research, find real people in the real world to go and research and organize that. And so from start to finish, this stuff can take half a decade at a time. You think of things like the annexes with the EBCs. These are 5-6 year projects often, to reach broad conclusions on things. 5-6 years, half a decade is an eternity in industry from a progression of technology sometimes and innovation, which means by the time people are on the ground actually measuring stuff, they can be old products. And even if particularly the bigger the study gets, you're going to have a spectrum of things that are going to be looked at. So you might have homes that were built 5 years ago, even so, or even older than that. So often, and you're absolutely right, the results and the conclusions that are drawn from quote unquote the real world that's being monitored, you're going, yeah, but we're 2 versions on from that product now at this stage. I've heard you say that so many times in conferences where you go, this is outdated thinking. We moved on from this in 5 years ago.
And of course, it gives the state of art of how ventilation is. I mean, take a town or a city, and you take a living quarter, and 100 houses. You have the state of the art of how ventilation is incorporated in these houses, but the ventilation units or installations might be from 2 years ago, but also from 10 years ago, and also some from 20 years ago. So what you're actually measuring is a big gather of all kinds of different stages of innovation, and this is exactly right. If the viewpoint is how is ventilation right now in the houses, but when you come to conclusions that already lead to the units that we have on the market already for 5 years, then it's a pity, because then it would be nice if they for matter of speaking, call me first and tell me, okay, what is your newest and your state of the art on the market at now, and then I can help them.
I can imagine that being reflected across all sorts of we're talking obviously here about ventilation and Zehnder with a real focus on balanced whole house heat recovery, but I imagine that applies across lighting, acoustics, all sorts of sectors where there's this innovation happening, and an industry, to a fault, sometimes will also innovate before it's ready. And is prepared to make mistakes and can go bust, particularly the smaller companies and the innovators and the startups, that are coming up with wild ideas and operating in the raggedy edge of industry. Innovation's moving pretty quickly, and sometimes it works and sometimes it just doesn't. It's just and that's just the way it is. So you can understand how academia can be a little bit conservative, equally looking into that world, going, well, look, it's fine. We get one shot at this, But if I start incorporating an idea that's just nonsense, it's going to seriously affect the outcomes of the study. That they want a little bit of balance in there. I imagine that when they're looking at innovation, that they know that it's got at least half a chance of still being there in 5 years, because that happens too, doesn't it? I mean, you see this in industry that the stuff just comes and goes because it just wasn't a very good idea, at best, and at worst, sometimes we see snake oil products, that are at best misleading. And that can be a challenge as well for academia, that it finds itself being pulled into rabbit holes that it doesn't need to, because you're then trying to unpack why something is fundamentally flawed, which is a different problem.
Can imagine.
Where this was leading to is ultimately that there's also fundamentally, I think, between industry and academia, a friction. And I think that friction is obvious because industry has a job to do, and that is to sell products. And the bigger the company gets, the more clever people it can employ to strategically think about the direction of that business long term, how it integrates into regulations and standards, who's looking at what, how to be competitive in the right ways against other organizations, what kind of information you want coming out about the business,
I hear you.
that's just the way it is, that the companies are heavily invested in reputation and brand and longevity and sustainability in the sense of having a business in 10 or 15 years, managing risk, public relations.
Yes.
There's a lot at stake and a lot of people employed, and often for good reasons. That they've got people's livelihoods and a business to protect, and yes, shareholders.
True.
So there's this fear, I think, in research of engaging sometimes in industry because you feel that it's an animal you can't control somehow, that you're being directed, or there's stuff, you're seeing half a picture, and the picture that what they want you to see, and all of that. And I think everybody gets that, that's a time immemorial story. That's the story of industry and research going back. But you and I have had this conversation. It feels like a missed opportunity as well. With all that goes with that, and we have to be mindful of it. There's opportunity here that if we're fearful and don't handle this in the right way, you miss that opportunity to lean on all of this brilliance and resources that come with industry.
My experience in my company at the moment, Zehnder is international company. It has a lot of geographical spread, but also the solutions that we have come from a very broad ventilation solutions. So there's exhaust ventilation, there's decentral, there's central, there's recovery ventilation. We have all in the house. So when I'm doing research, I try to find out not what suits our product database best, but it finds out what is best in which situation. And I hope to give that story to conferences, academic conferences, but then backed up by profound research criteria. So that is what is interesting for me. Exactly what you say. I can give the conclusion that solution A is better than solution B, but do you see it? Have I done it the right way? Do you see it the same? It's not because I want to make my company last, but it's because I want to have a clear understanding of the difference between solutions.
And I think, and you see it, it doesn't take long if you're in a particular vertical or market you learn very quickly who are the genuine people and the people that are doing the research and are presenting it in the right way. What you don't know when you're looking into that world is who's behind those people. What are the directions and steers that are being given about what work can be done? And like you say, you might have a good idea in your research that A is getting a better result of B than B. But from the outside, the question when you look at that kind of stuff coming from industry is are they presenting A because that's what they want to sell next, rather than that's what the data says. And that's always I think that's the natural reservation of people looking at research and information that comes from industry, is that you just never that it's always tainted with this idea that there's a motive behind it to sell a particular thing for a particular reason, and understandably so. But you see that bridge being crossed well, and mine and your goal is, how do we get that to happen more often? That's the thing. It's not. It's that feeling's never going to go away from people, because I think, and it should be there, because that's what protects us all. Because we've seen over and over again industry do bad things when it comes to the direction of research, right? That's happened and will happen constantly. But we equally know that research is resource limited, desperately needs contact points in the real world, and to understand how this stuff translates and has impact in the real world. We hear this word impact all the time out of research. You do not, and you will not get that unless you can find ways of engaging with industry. And it's a fascinating bridge, actually, isn't it, when you think about it, how we create mechanisms to really help and facilitate both parties work better and well together.
And maybe it's less obvious, but if I'm honest, sometimes I see in the academic world the same, like research groups from here and research group from there, and they're always telling a different story because they want to give proof of they favor a way of thinking. So there could be some bias there as well, trying to get funding for their own kind of work.
Oh, big time. And what about the famous one of needs further research?
Exactly.
Yeah, how many times in industry you're going, really? It seems pretty conclusive to me, but it's very difficult for academics to say, actually, you know what? We've done quite well here. I think we can draw some pretty solid conclusions, but that doesn't help them for the next bit of research.
They cannot say, okay, but maybe the rest of the work can be done by this other research groups.
Yeah.
But anyway, that's a little bit for laughing. But I think in the end, what I try to do when I give when I write articles, I'm talking about technologies. I'm not talking about brands. So if I'm trying to find the advantage points for a certain technology, I have to give the technology a name, and it's not about the brand. So, and maybe also the academy can help me to do different brands with the same technology. And then you're, how do you say that? Brand irrelative? No. So the brand is not the thing that is important, but the technology is the new technology that has been materialized, and therefore the industry can also provide the numbers in the real world, as opposed to maybe research groups that have to do it with simulations.
Yeah, I think it's interesting you also get this life phase of certain technologies where products are fairly new on the market, ideas are fairly new on the market, the unique selling points or the propositions of that product stand on their own 2 feet often. So when research is being done around that, there are quite clear differentiators between one way of doing something and another way of doing something. So the competitiveness of industry in that scenario is really based around whether one approach works better than another, right? And that can be quite clear, you know. Where it gets interesting, I think, is where you get very mature technologies, and let's take heat recovery as a good example of that. You know, fundamentally, a heat recovery that's two fans in a big white box with a heat exchanger and four pipes coming out of it, it becomes less clear to differentiate between one brand and another, right? Because that technology, particularly in its second decade of mass production, the innovation starts to align to a large degree, particularly amongst good manufacturers, right? And they'll often OEM a lot of the same components at some point into those products, because there'll be clear winners from the component supply chain floating to the top in that process, as well as the market becomes mature. So what's interesting in those scenarios is that brands become more and more desperate then to differentiate on smaller and smaller things. You know, they're searching for how does my white box with two fans and a heat exchanger differ from somebody else's white box? And that's where, so it's really interesting when you see industry involved in research, how that evolves when a particular technology is matured. And you're saying, well, actually, it's the subtle iterations at this stage. You know, we're the good analogy is electric cars, right? Is that the assumption was a decade ago that batteries could only do so much in an electric car, but what we're getting out of a battery from an electric car now is so dramatically different. And that isn't necessarily, I mean, yes, the cell technology is improved and all of that, but our ability to finesse every inch of use out of that battery and the heat that it produces and the way it cools and recharges and all of these things means they're vastly different vehicles than they were a decade ago. Fundamentally, it's still a battery with an electric motor, right? And absolutely the same applies with these mature ventilation technologies. The differences between the good ones that have been around a while and the ones that, you know, and I see it all the time, people that are just entering the market and they're on version 1 or 2 of their product, even if they do have the history of the more mature companies to lean into, they can be so far behind technically, those products, because they just haven't had that experience of innovation and iteration of those products and finding what really works in different markets.
Yes, so there are. I think there are two worlds there. Maturity of a solution. We can think as ventilation specialists, we can think it's mature, but we have to educate a vast amount of people that it brings you more than just opening a window. So for one reason, there's enough work for 20 years to tell that story. So the matureness, what do you say? The maturity is not as well spread, known as we think. And the second is, yes, there are other companies that may enter the market with similar ones, but then of course you have to discriminate because the world around us is also changing. It's not that that's a standstill. Electricity prices will vary. There are wars going on. So you have to think ahead in the future if this solution will still bring the optimal solution in 5 or 10 years. And I think when you have enough knowledge on every aspect of ventilation, then you can make proper choices there to bring even further innovations.
Yeah, no, I was only talking earlier this week, Bart, to I know a friend and colleague of yours, Paul O'Connell from Munster Technology University, and we were
Paul
talking.
Sullivan.
Paul O'Sullivan,
Yeah.
sorry, beg pardon.
Yeah.
And we were Paul O'Connell's the rugby player from Munster. That's what.
Better known for you than
he,
for
he'll,
me.
he'll let me off that one for that reason. The this idea of global warming and the changes in outdoor environment, that what works now may not work in 10 or 15 years, or have to work in a different way, or suffer different pressures. These kind of things, these subtleties and nuance really matter in product innovation and design. So even though it might remain a white box with two fans and a heat exchanger in it, the job it has to do might shift quite significantly over a period of time, just on the nature of the kind of environments that it's going into.
When I entered the company and I didn't know anything about ventilation, then I would think it's a box with two fans. But right now I totally disagree. And there are so many things to bring further in the future that it's really nice to think about that. What will be next? And this cannot be done by companies that the first goal is to reach the budget or to reach the final sales. No, we have to bring technology that work for the longer run.
Yeah, and that's an interesting point you raise, actually, and it's one of the big dilemmas of industry, I know, and manufacturers, is that the surface level assessment of their technology is often done in very simple terms, and often there can be a race to the bottom in trying to achieve the best possible results in that assessment methodology, whatever it is, because ultimately, as you said at the beginning, you're often assessed in the first instance on the brochure and what it says in the brochure. And if I can make my product cheaper than your product and achieve a similar result in a brochure, for some businesses that's the goal, right? And there are different market segments. There are premium market segments, there are mass production cheap segments, and there can be different imperatives in all of them. And that's the challenge, is often the way that you're viewed and assessed as a product, beyond the long-term brand recognition, is on that surface level. Do I achieve the same rating or a rating or whatever that assessment process is, right?
Exactly that, because regulation brings an interesting aspect to that, because by nature, I think, by the way, any regulation and laws, I'm not an adept and a real, I do not know a lot about it. I only know a bit about Newton's law, but not any national laws and regulations, because regulations lag in time behind technologies, because they try to control all the existing technologies. And then what you see is that the companies that go for the cheapest product, they only try to give the cheapest, so the minimal solution that complies with regulations. Whereas, of course, the goal could also be to bring the best solution even further than regulations. And I think that's an interesting way to look at it. Why comply only with regulations if you can do a better job?
I'll have you back to the podcast in just a moment. I just wanted to very briefly tell you about Farmwood. Farmwood is one of the most successful SME ventilation companies in the UK. Multi-award winning for their work in ventilation, compliance and health and safety. Farmwood has spent 23 years becoming the go-to service partner for a range of UK and EU ventilation manufacturers. They work on commercial, industrial and residential projects, and they're all about linking up academics, industry and engineers, driving real regulation reform, and most importantly, making sure the buildings we live and work in are healthier and safer for everyone. Their managing director, Nathan Wood, is a fellow campaigner of mine and someone I respect deeply. He is the chairman of World Ventilate Day and was previously the indoor air quality chairman at BESA. He's now leading the charge for competence and compliance across the ventilation sector in the UK. Farnwood are also really big advocates for apprenticeships, helping to develop the next generation of HVAC engineers who are going to keep our buildings breathing. They're a company that genuinely cares about buildings and people. You'll find more details in the show notes and at farnwood.co.uk. Now, back to the podcast. I love this conversation, the conversation of the minimum becoming the maximum, the floor becoming the design intent, and the challenges that come with that. And that a bit like the academic industry friction that we've been discussing, that again is a time immemorial problem to solve, because they have different jobs to do. And I that's what I find fascinating about this podcast, is sitting in this middle ground between industry, academia, and regulations and policy, how those three interact, because they all have different jobs to do. They all have different imperatives. They all come from a different perspective on things. But they all have to work together. Like the three are a trifecta that has to work. Otherwise, you see failures in the real world. You get regulation wrong if it's too far behind, or it's too weak, or it doesn't set the floor at the right level. We see problems, and we see that manifesting in building failures and people suffering as a result of it. We see industry innovating too hard without the checks of regulations. We see products being made that aren't safe or don't protect people in the right way, and so it goes on. It's a wheel, and the three have to be able to interact.
Or even they comply with certain, like there was an interesting discussion that I had a few years ago, when ventilation units could bring a maximum of X cubic meters per hour for a house. But in reality, they are not set at that amount of air, or they bring the fresh air, but who knows where in the house. I mean, you have to bring it to the right people at the right time. And I had a comparison with a hospital, maybe, where the supply of medicine, the stock, could be right. But if you don't bring the medicines to the people that need it, then you're not doing the right thing. So even the ventilation unit has to work in its ecosystem with the distribution, with all the filtering, with all the grills, etc. And the whole installation should do its job.
No, I agree completely. There's a couple of definite things we see all the time when we look at the difference between what we see in industry and through manufacturing and the sale of products to people and to the coalface, and academia. And one is the difference between real world performance and modeling. And I think that's something that we can really help as industry, is say, yes, but that and what's the saying? Models are never accurate, but sometimes useful. That there's this, we can, the reality of how products work in the real world, and the kind of performance you see is data and information that is a feedback loop that's desperately needed in modeling, isn't it?
True, because I think simulations, a computer simulation, dynamic simulation, can be done a bit easier, especially when they're in a research group, and they should be used when it's there. So it's a bit easier to give a student that assignment than to set up a whole real world measurement campaign. Everything is fully, I can understand, but this gives a certain simulation or model reality as well. And not to say also the models that are being made for regulations in a national body, because then the regulation defines the model. And then I see a lot of research done on the model, which is just a mirror of the reality. And if the model is not right, then you cannot make conclusions from the model. So I'm really fond of really checking the models every time with technologies in the real world, and we could bring that.
Yeah, absolutely. And the advantage we have now is that we're able to measure the outcomes in ways that we couldn't have even dreamed of 10 years ago. That our ability to measure air quality and thermal performance and all of these things has just changed out of all recognition, even in the last decade. So that's made a huge difference, is that our ability to check and feed back data into these models is moving really rapidly.
And there's also the link between the industry, because now maybe the academic world doesn't bring all the sensors with all the wiring additionally into a home environment, but we have also solutions that give you the opportunity to sensor a lot of things around the unit. So but of course then the reliability of our sensors comes into play, and there an academic check would help as well.
Again, we were having this conversation with Paul. One of his bits of research has been looking at that, the difference. So in their case, they've been looking at heat pumps. But one of the fascinating things, I think, particularly about engineering solutions for the built environment, is there's often a lot of edge data being recorded that isn't being collected. So what I mean by that, for people that don't understand, is that fans and sensors and things that move and switch on and turn off and change something in machines are doing so because of data internally, sensors and thermocouples and all sorts of stuff, and they're using that internally to make decisions about how whatever that product is, how it operates. So there's a lot of data being held internally at the edge in these products that is enormously valuable, actually, if you can extract that and understand how those, because to get that kind of data through third-party measuring tools is enormously expensive, and often, I know academia has complained for years that there's an enormous amount of really valuable information being collected about the performance of systems and the built environment that we just can't get to because of the way that it's held by manufacturers. And when manufacturers understand that better, they can provide routes into that resource that haven't been available before. And I think that's a really fascinating area of research at the moment, is this being able to extract through things like APIs data that's available in machines of various descriptions and pull it out to understand how these spaces work. I use the car analogy all the time, but that happens at scale in cars every moment of every day. There are sensors collecting information that's stored in computers on cars, and when you take it into a mechanic, he plugs it in and he knows that sensor number 3 on the oil filter has failed, or that this is the viscosity of that, and that's why your engine sounds the way it does. That they've been doing that for years in the automotive industry.
Yeah, I know. And one spin-off of the that I visit conferences is also that I sometimes work in research groups together with universities, knowledge institutes, and industry to bring sometimes this data also forward, so that the academy can work on them themselves. But again, cooperation is incredibly necessary, because sometimes they do not understand our algorithms. And once you understand these and you have the knowledge, then you can not have the data only as raw data, but you can make knowledge of it.
One of the things I did want to talk to you about, and it's always an interesting conversation I have, it is when we see academic research being done on the built environment broadly, and here I am talking about ventilation specifically. Often what we find is that we see studies effectively measuring poorly installed ventilation systems. So academic research will start out saying, we want to really look at how heat recovery performs in these types of buildings, or the differences between heat recovery and exhaust systems in this type of an environment. And they have a whole bunch of research about collecting air quality and doing surveys with homeowners or whatever the scenario is. And time and time and time again, the conclusion out the other side of it was, yes, that was a great idea, but we found 75% of the heat ventilation systems weren't working properly. So what we were actually measuring was shit ventilation. That's a problem that we've got to be able, if ventilation wants to be able to put its best foot forward and show the capabilities of good ventilation in homes and the delivery of good outcomes, the alignment with standards and regulations, we've got to find a way of being able to have homes that actually do what they're supposed to be doing. And you must be incredibly frustrated. And I know, I've been involved with a manufacturer before. If you know that you're going to be involved in a study, the good manufacturers will bend over backwards to make sure that those systems are working the way they should be if they're part of a study. But we see it over and over again, don't we, that the main conclusions coming out of work that's looking at air quality outcomes and ventilation outcomes in all sorts of buildings predominantly becomes about the failure of those systems to be doing what they should be doing.
Yeah, and it's not only fault of installers or anyone's fault, but we have in our solutions, we have a chain like the components that are really high-end components from our suppliers. Then we make a unit out of it with our design, and we're responsible for the best unit there. Then the installer should do a good work to install them right. And then, of course, the operational phase. In the operational phase, the family, the end user, the owner should do good maintenance at the filters and so on. And if one of these links they break, of course, then the whole chain has been lost. So in doing these researches, I had 10 years ago the Monacare study in the Netherlands, and we tried to find a good number of households to do a comparison between ventilation solutions. But when we did the criteria of good installed systems, then the numbers would reduce quickly down to a few of them for this solution and a few of them for that. So, but you have to do the check first. And of course, we're doing our utmost best to make as few installation failures as possible. That it is difficult for an installer to do it wrong. That's how we do our design. And I think what helps as well is that we give a lot of trainings to installers here, so that they can get a good idea what is the good way to do it, the best practice.
I think at the heart of that problem is how ventilation is valued. If there isn't enough capacity in the value of ventilation, then it becomes a very lean product. And I don't mean that just the actual ventilation product itself, but the design, the installation, the serviceability, all of that. Because if it's not highly valued, then there isn't enough fat on the bone to be able to provide people with the capacity to make sure that these things work. And this is the thing that frustrates me about ventilation, is it's an engineering problem to solve, right? Ventilation is predominantly engineering, and all engineering works off of this premise of redundancy, that you take account of the unknowns and the unintended consequences. And yes, ventilation's a supply chain, and quite a long one sometimes, between design, both from a manufacturing perspective, but also design on how these systems go in, all the way through installation to use. it is quite a complex and long process with different people with different goals and perspectives on it. But it's just engineering, and there are plenty of other engineering practices that take account of that problem perfectly well, because people's lives depend on it. And I think this is the challenge often, is ventilation isn't seen as a life safety system. It's not valued highly enough that we feel that we can build these redundancies in. And it gets back to this kind of the minimum becoming the maximum. We set the bar low. This is what we have to creep across to be acceptable for whatever thing I'm being measured on. And we don't build in enough bandwidth and whatever a big enough spectrum of performance or enough redundancy and capacity of these systems, all of these things that are basic engineering terms that mean that, as I say to people, look, you need to be in a scenario with ventilation that, look, if you got it wrong, we can turn it up a bit and it won't be a problem. And if we've overcooked it a bit, we can turn it down a bit. Like that's good engineering. You know, we can make a decision downstream that doesn't affect the user of that thing. It doesn't become inefficient or doesn't become noisy because of that adjustment. You know, it's very difficult. There's always an unknown in ventilation and always will be, and that's the use and occupancy of those spaces. We have to design systems that have capacity and flexibility, that those adjustments can be made downstream in a way that doesn't affect people. But currently that doesn't happen. And what happens is that when systems are designed to meet a minimum, whatever they are, whether it's the energy performance label of the fan or whether it's the regulations in country for the minimum flow rate that you need in that property, when you design to that minimum, any failure, as you say, in that part of the supply chain, the default position will be non-compliance. So is it any wonder, you know? And the big studies we've seen out of places like the UK, that the numbers have been horrendous. You know, there was a big study in the UK on whether natural ventilation was still fit for purpose in modern airtight homes. It's quite a famous one actually at this stage. So they asked developers that were building modern homes to put up homes that were having natural ventilation with intermittent fans in them. A third of them didn't have that at all, and they had no idea. It turned out to be decentralized mechanical extract system. And between those two systems of the houses that were offered up by the developers, which you'd have assumed they'd have gone, maybe we should give them the good ones, there was a 95% failure rate to meet even the minimum standards. Like 95% of the homes didn't even meet the minimums. It's shocking, like, you know, and it just shows where there's a big gap to close in ventilation performance. And it's not that we've got the technology. It's not a technology problem. It's a process and delivery problem in a lot of cases.
Despite our effort to educate people that we really need fresh air for good health, it's still difficult for people to feel if they are not ventilating right at this moment. Then maybe in 10 or 20 years they could sacrifice sacrifice their health from it. Is that right said? But despite that, maybe in future, I think this ventilation as a service aspect will become more and more known. So the responsibility for bringing fresh air in a home is not only the responsibility of the house owner itself, but is provided by a house builder or by even a manufacturer, so that we sell not the product, but we sell fresh air. We sell good air quality.
And what are some of the ways that Zehnder are trying to close that gap at the moment? I mean, I know you have these kind of knowledge centers and training centers, and you're well known for that in really trying to build up the knowledge base of the supply chain, so that the people installing and designing these systems are the champions for the outcomes as much as the brand is?
So on a national level, we give a lot of trainings to installers to give them, to really help them not to make the mistake, so that end users do not get the fresh air they need. And of course, on a higher maybe education level, I try to bring the new aspects, the new technology to these trainings. So I hope to give the basic knowledge in the future for these trainings. And of course, we try the best as we can. Also cooperating with maybe national bodies, or maybe the asthma fund, or whatever, to raise the awareness why you need fresh air. As always, but even more when you build airtight houses. And of course, as already said, we know this as ventilation specialists, but it's not something that you're thinking of as a layman every Tuesday at 9 o'clock when you're bringing the children.
I love your job title as knowledge consultant. That fascinates me, and it sounds like a great thing to do. Like, describe your week to me. What is your job? How do you describe it to people within Zehnder?
Well, it's giving and taking. It's taking the best technologies that I read from maybe colleagues or academy. It's taking the best of monitoring that we do from our own products. So really trying to gather all the data and transforming this data into knowledge. So really aggregating, really trying to get a figure of how is it working. And that takes me maybe 3/4 of the week, and then the rest of the week I am training. I am training my colleagues. I am training maybe interested customer groups that visit our factory in Zwolle. Because in a way, I also educate the people around me so that they can bring the story to the world.
What are your touch points then within Zehnder? Are you kind of predominantly working with R&D, with product managers, with the operational side of stuff? Is it quite a broad remit that you find yourself in lots of different meeting groups, bringing what you've learned and the knowledge from the knowledge centers into the various different work streams within the brand?
Because in Zehnder we are organized around different. Let's say the commercial side is in various regions throughout Europe and beyond. But there is also a group functions that do their work, obviously, for the whole international Zehnder Group. And I am located in Zwolle in the group product management, and very close to the marketing also from ventilation. So here as you know, I mean, giving trainings or giving lectures, it's not me learning them only. I learn a lot from the questions that are asked. So within this contact with product managers, I get to know what is not entirely grasped clearly, and then I can do my work to give them better understanding.
I always find those dynamics fascinating within companies, the interactions between engineers and product managers and marketing and sales people and people like yourself, where you're trying to find the balance of engineers running off and designing things that are possible but not sellable, people wanting stuff that's sellable but not engineeringly possible, and trying to find this way of progressing within a business that creates products that work, do well, and ultimately have a market, that somebody.
And I see that daily. happening. But the nice thing about my function is that you can give a fundamental background or real arguments why it's flipping to one side or the other.
That was always and is the best part of industry for me, is that seeing that dynamic when it's working well. The interplay between the people that are working with the marketplace and the people that are engineering and developing products and doing R&D, when that's singing, it's an exciting place to be.
Yeah, because from the monitor project, what I say, if I see good things, then I bring it to marketing department, or I tell it in lectures. But of course, when there is room for improvement, I can immediately go one floor down and tell it to the ones that are developing for the next generation.
Okay, so as somebody at the bleeding edge of technology and ventilation, Bart, where do you see ventilation going next? Where are the innovations coming from, do you think, in this sector?
There's a lot to tell, of course, but maybe also not for me to tell, but only in future you will find out. But there are, of course, different directions, and I think the first one is obviously that we are not talking only about new build houses. So ventilation was steered a lot the last 10 years maybe by the sustainable houses of the future, so the new build. But we have an enormous assignment in the renovation, and it has been picked up by us and by others as the assignment for the coming 10 years. So what we find here is how can we bring the necessary steps for people in renovation to bring a better renewal of their air in the house, so for better air quality. And to my understanding, I can give the best solution, the most intelligent solution. But if it's not possible for a renovation, then of course you have to give different steps on what people can improve, which is within their budget. And I think that's a clever way to do solutions that work for every type of step that you take into a renovation. So you want to give them solutions that work in their environment. That's one thing. Renovation.
That's really interesting, and it makes me think of an idea that came out of work in the UK that was looking at moisture risk in buildings, and it was this the fundamental principle of the difference between a theoretical new build and a building that already exists, and that they coined this term ADT, as designed and theoretical. So this idea that what you're doing with new build is you're designing to the art of the possible. You don't know how it's going to be used, but it's an approach and a principle that's embedded in design theory, really. But you've got a whole swathe of buildings, which they coined the term as built in service, ABIS, that you not only have to work with the building as it presents to you, but you're also dealing with a building that has a history. So what's interesting about that is people bring expectations of things like performance to bear that you don't get in a design theoretical space before somebody's even moved in. Yeah, and a good example of that with ventilation is that somebody may not have been used to mechanical noise from a ventilation system because it was a naturally ventilated building. So their expectations of how that should be are going to be different to somebody moving into a space that is already mechanically ventilated. And one of the ways that manifests all the time in retrofit is if we have to add a perforation to the fabric of the building, a hole in the wall to let air in, or a trickle vent to let air in.
The central solution.
That might be a penetration for noise ingress that was never there before. So although you're providing one solution, the unintended consequence of that is you've now got a noise point source that was never there before. These things don't exist in new builds. It's these subtleties of not only the obvious ones of how do you fit a system into an existing building, but the lived experience and expectations that come with somebody owning and living in a home, or an office, or whatever that space is. So it's a fascinating, it's a really find fascinating dynamic in getting good outcomes. And it's a space that there's definitely a lot to learn.
I think this was also a nice thing that was brought up in the conference in Montreal last year, that we more and more get accustomed as suppliers of ventilation solutions to discuss the right solution for the people that live already in the building, with their habits and with their experience, with their expectations, as you said. So rather than giving one main body the outcome, you have to deal with every family as it in its own. Am I clear when I tell it like this? So we have to bring more solutions that suit more people. So sit down with the family, ask them their expectations, and give them the solution that they are helped with, rather than the only most intelligent solution that is for new build. So that's one thing, and I think that's a good way to go.
This idea of kind of going back to the science a little bit just for a moment is the citizen science side of this. What we haven't seen in a lot of ventilation and air quality work is the true integration of citizen science into the research as well. So if we, particularly in renovation, so if we want to get good outcomes in our existing stock, we have to work with people, that we build buildings for people, real homes. So we have to understand how to work at a citizen science level. And that means involving people, real people, in the development of the research. Even at a fundamental level, are we even asking the right questions for the people that are going to be in these boxes that we build for them? And I think that's a really fascinating frontier of science, actually, is increasingly seeing citizens being brought in at a fundamental level at the research to not only participate in research, but actually develop the questions and the structures of that research in the first instance. Because one of the things that I've learned speaking to citizen scientists is that if we want to work with people and understand outcomes in spaces, there has to be something in it for them too. We can't keep turning up into people's homes and extracting data and questionnaires, and that you only get so many goes at that. But if you're genuinely involving people in citizen science projects, you get a much longer run and a much more deep run at gathering information from those people and those spaces, because they're involved in the process, they're invested in it as well. There are unintended benefits to them being involved in that process as well. And that for me is a really interesting frontier. Particularly, it just reminded me of it when you were talking about retrofit, that these are people's homes often, right?
Yes, although maybe I'm thinking personally that in a very abstract level, this is also a transition period, because in all the times 20 years ago, 30 years ago, no one was still talking about ventilation solutions, because for a leaky building, you just it sometimes is good and sometimes bad, but nothing that can be done about it. Now we have to educate people that they really need some system to bring them the clear air that they want. But I hope this is transitional, because in later times, it's fundamental that people get a ventilation solution for air renewal in their house. They don't have to think of it. And also the solution is working without interfering a lot with it. So it's largely automatic, bringing the fresh air that they want. Unless they want it other ways, then they can turn it down or up a bit. But it's working for them. It's only logical. So we're in a transition period where we have to educate people why they need it. But we do at this moment.
So that was one.
Yeah.
You had a couple of other areas to watch out for.
There could be other directions for innovation. I think we touched upon it some time ago. That I think the components like fans and exchangers and filters, they are good from the suppliers. You have to have good suppliers for that. But if the components are right, then we are going to more and more automatically control the ventilation for different conditions and different preferred levels of the customer. So there's more and more sensors going into the units, and then the components in itself are not very important, but the sensoring is very important, and what you do with it, the algorithms. So and that brings maybe the possibility, but now I'm thinking about quite ahead in future, that we are bringing ventilation as a service. So we're not selling the unit, but we're selling the clean air, and we or a home builder can take responsibility. If you take our system, then we bring you a fresh house that you live well in and you feel well in. We need connected units then, because we need some understanding of how the unit is behaving. And then if we can go easily there to do the maintenance to filters, or by any chance replace a component, then the end user should not worry about that. We take responsibility.
Yeah, that these as a service models, I think, are fascinating for manufacturers, and you see it at a high level. You know, there are stories after stories of Apache helicopters, Rolls-Royce engines. There are plenty as a service models that have shown that one of the things that they do is that they change the dynamic of what good looks like for the provision of that service as a whole. And it means everything has to sing. You know, the profitability, which is the driver for industry doing something like that, is bound not just within the margins of the product, but the entire process from design to supply to operation. And it tightens everything up. Everything has to work. The entire organization has to be able to work in a way that delivers the outcome that the customer needs. And that invariably has been very helpful for those sectors that have done well. And, you know, the aeroplane engine is a good example of that, you know, where you train pilots to fly a plane in a better way to get a better longevity out. You know, it's a full feedback loop cycle that you know, what's the saying? The Rolls-Royce, they don't sell jet engines, they sell air miles or uptime. You know, that it becomes a different thing, right? And everything has to work, and that can only be helpful because that effectively closes that performance gap. It has to, because that performance gap is lost profitability. You're saying, I'm going to deliver X. Every time there's a gap, that's not on the customer, that's now on the supply chain. And it's it has to be a very confident place to operate from.
We're gaining experience about that, because one of our business segments is also filtering air for industrial air places. So if you have an industry hall that has a lot of dust and fine dust in it, then this segment really is not selling products, but it's selling the solution. It's selling the clean air, and we keep responsibility for the good working of the product. So we take care of filter replacement, etc. But of course, in industry, this is a different segment. In the housing, in the residential ventilation, we're still far from there. But who knows? Who knows?
Yeah, there are hybrid versions of this. It's very unlikely that a lot of segments are going to jump from a traditional capex sales model straight to an as a service model in one leap. There'll be middle ground hybrid versions of that in between, or as something I want to chat to you about, integrating with other systems, that it's not ventilation as a service, it's building performance as a whole as a service, and ventilation is part of a bigger, which it is, we see that in how we frame the performance of indoor spaces increasingly in this world of indoor environmental quality. Ventilation does not stand alone as the only thing you want to measure as a good outcome in a space. So it's very likely in a lot of circumstances that kind of as a service approach will be part of a bigger picture somehow. And that it's that scale that makes it possible. There are several companies that are doing ventilation as a service, but typically that's either being driven by very specific process needs, like you say, like halls with filtration needs and so on, or scale as in size and scale of the problem. So there's a company in India I've spoken to that does ventilation as a service, but they can only operate at a certain, it's kind of shopping mall, big office complex scale, because you need the scale for it to work. The interesting thing will be how far can you trickle down to, can we get all the way down to ventilation in homes? Yeah. That's the fascinating thing. I don't think we're quite there yet, but I think we might not be as far away as we think, particularly if we integrate it with heat pumps, thermal storage, solar PV. That ventilation is part of a broader service of measures.
That gives the perfect link to the third innovative direction, where you have the combination of ventilation. It's not a standalone solution, but it works together with heating and cooling with air, with the ventilation air. So that is really a thing that, let us call it multifunctional units. There are various ways to call them, but multifunctional units bring ventilation, heating, and cooling. Possibly also humidification, dehumidification, whatever. And that opens a whole world of possibilities there.
I'm both excited and nervous about that prospect. And I think that's, for me, has been born out of years of heating getting involved in ventilation and screwing it up royally on us.
Yeah, I can imagine.
The energy is, the energy, and understandably so, particularly as ventilation and air quality has been in its infancy, has taken a back seat typically in the built environment to energy and thermal comfort. And what's typically happened when we've started to integrate heating with ventilation is that poor decisions are made on ventilation and air quality outcomes in lieu of thermal comfort or something else, whatever it is. And so we've not done that very well. I get the art of the possible. And I asked this question, Valerie Le Prince, I was talking to her once, and we were talking about the benefits of demand control ventilation. Another, we talked about it loosely here, this idea of controlling ventilation based on pollutants. And I said are we ready, in the sense that we've had very basic kind of guidance and goals for ventilation up until now, of certain air change rates or litres per second per person or whatever it is. And every time we go and measure it, we've been failing to do it very well. So if we can't get the basics right, how difficult is it going to be to unpack outcomes, if, like in the demand control sense, if it's not just whether or not we achieved half an air change an hour, but we've also got to factor in emission rates of something? Was it the emission rate that screwed us up, or was it the the ventilation flow rate? Was it the algorithm that was controlling it was off, or was it the, it becomes really complicated really quick when you add those kind of levels of complexity. And that's just one dimension. That's just the complexity of controlling ventilation based on outcomes. I think the fascinating thing about indoor environmental quality is this interface between thermal comfort, acoustics, air quality. Some of it's about comfort and optimization. Others is about thresholds and safety and exposures. Like, there's a lot of conflicting things going on when we start integrating systems, and look, we do that again in the automobile world very well, right? That it is possible with technology and controls and data to, you define the outcome that you want, and the system figures out the best way to do that.
Optimizes to do that.
Like we know it's possible. That we're just in this really interesting phase, I think, at the moment, where we're starting from here. We're kind of still on distribution.
I know your nervousness for this, but I think this is exactly the point that any combination of ventilation with other functions in the house should not be taken lightly. It's just not wiring two systems together and hopefully it's done. I'm always thinking of the old radios that we had. We had two buttons, one to put the volume up and down, and one for frequency adjustment. But suppose you have one button for that radio and they do both things at the same time, then unlikely things are happening. You cannot predict what is happening. So this is the same when you control ventilation and heating. I mean, who knows what happens when you leave it to lay people. So we have to think hard how we do that integration. And that's what we do in these multifunctional units. We have to think hard what gives the best outcome for preferred conditions. I mean, there's a lot that changes even within a building throughout the year. The internal conditions, the outer conditions. So the centering should be optimal first. Second, you have to have a clear indication what the end user wants. And maybe you give them choices, but you don't want to give them too many choices, like not 7 options or 100 parameters. But you should have an idea. Are you an ecological person? Like, do we have to go eco and save as much as possible with a little bit of compromise into your indoor air quality? Or do you want the best air quality, the best temperature range, but then you pay a bit more for it? So in these scenarios, we can tune the system to give the optimal result in future in these functions.
Yeah, and again, I am optimistic in the sense that this is well established science. We know how to balance the psychometrics of moisture with thermal comfort and air quality. Like, that's been done in HVAC for a very, very long time. We know how to achieve the things we want to achieve. We just have to find ways of presenting that through technology and user experience to people in a way that we get the outcomes that we want. And for me, the big thing is being able to judge and assess that we're getting what we pay for. And I think that's probably the bigger challenge, that manifestly what's been happening in ventilation so far, and people that listen to me know I talk about all this time, is that this has been fundamentally a consumer protection problem in ventilation thus far, and that is that we haven't really been getting what we've been paying good money for. in a lot of the ventilation world, and that manifests in poor outcomes. It's not that people haven't been buying fans; it's just that they haven't been getting what they should be as a result, right? And I think when we get more complex systems, one of the things we have to think through is how do we measure success? Like, how do we determine that that person got value for money out of that process? Not just from an energy perspective, but can somebody walk into a property and determine that that system is doing what it should do, and how to correct it if it isn't? And as we make these systems more complex, that gets it's not just twice as hard when you have two systems together, it's 4 times as hard to do. And when we bring 3 systems together, it's not just 3 times as hard, it's 12 times as hard. And so it goes on. And increasingly, and we see this through the work of energy in buildings and communities, that we're also having to think about homes as part of a broader system as well. That we've got things like energy storage and flexibility to consider. And actually, we're going to be offsetting certain things at certain periods for benefits later on in both the short and medium term. So that the buildings should be and can be incredibly complex systems if done well, right?
Yeah, and even the humans are also complex systems. I think when you are looking at mature technologies like heating, then everyone understands when the heating is doing its good job, because if you're feeling comfortable most of the time, you have some way of control over it, for your actual level of comfort. And everyone understands that when you have 2 windows in winter open, then you will never get the comfort with the same heating than before. So we know that already. With ventilation, it's a little bit different, because when the CO2 is coming up and you have some control over it, you're already on a high level of refreshment, but still the CO2 is big. That may be because you are with 20 people in that room, but people cannot really grasp the link between the two. So it's not that we're not there yet, but I hope with your support in air quality matters that people understand that when we're 2 generations from here, everyone will understand that. So then people will know we have a good ventilation system, and possibly also in combination with heat and cooling.
And I think it answers one of the not the questions, but the statements that I was making earlier about, mature technologies like heat recovery, that this game ain't over for a long time yet. There is a lot of exciting innovation to come. There's a lot of potential to work across the board, both between industry and academia, but innovation across sectors within industry, and working more closely with our heating partners and our lighting partners and all of the others. It's a very exciting place to be. And I'm sure your message, as is my message, particularly for the younger generation looking at what to do next. Engineering in the world of the built environment is really hot at the minute, and there's endless possibilities, no matter what your skill set is, coming into this sector. To that this space is just going to keep moving for many years to come.
The next point is also, can we talk as technical specialists? Can we talk in the same language as a normal family does? When somebody in the house wants to change something, but he gets 20 parameters that he can play with, and we're not doing it right. But hopefully, and we're doing that a lot, to talk in scenarios rather than in parameters. So he can set it to party mode, he can set it to away mode, vacation, or work in home office. And then the parameters are adjusted in a combination that suits the purpose. And I think that's also a direction to go with, especially with these multifunctional units.
Yeah. And I think that really shows the importance of putting people at the center of this conversation, that, we're building buildings for people. We say it all the time, but we've really got to mean it. And these spaces have got to work for people. And we've also got to, as you say, be able to communicate that effectively. I'm still trying to figure out how to communicate with my teenage daughters, Bart, never mind explain how to control the thermostats and ventilation system. So we need to kind of figure out how to do this by the medium of TikTok dance, but I think that's beyond you and I at this stage.
well, true, and we keep doing.
Yeah. But listen, it's been brilliant talking to you this morning. I knew it was going to be fascinating and really refreshing to get the perspective of industry and someone like yourself that straddles so well this gap between industry and research and academia. We'll put links to your work and what you do in the show notes, as we always do. But really appreciate you taking the time out of your day and talking to me this morning. Thanks a million.
Thank you, Simon.
Thanks for listening. Before you go, can I ask a favour? Before you shoot off to whatever it is you have to do next, or even the next podcast, if you enjoyed what we've been talking about here, please do spread the word and let's keep building this community. And don't forget to check out our sponsors in the show notes: Ultra Protect, Eurovent, Erico, ACO, Farmwood and Zehnder, all amazing companies, and without them this podcast would just simply not be possible. Check them out in the show notes at airqualitymatters.net, and do check out our YouTube channel. All this content is there, plus much more. See you again next week.